Hello, Math 20-1. So this is part B of our travels through 4.4 and about y equals ax minus p squared. You are, in this, going to be writing the equation. So in 4.4a, you did everything you needed to transform our basic little parabola of y equals x squared into this ax minus p squared plus q. And you graphed that. Now the question is, could you, with some information, be able to calculate the equation from that information? And that's much more powerful. And you might ask why? Why is that more powerful? Well, if you look at the next question, you say, well, write the equation of a parabola in standard form that has a vertex of 0, 4, and then passes through this point of minus 1, 6. So I can graph it if I were to just draw my x and y axis. And again, remember all the practical applications we've had with this. If this was, or when this is, because your job in your applications is going to come up with the equation to the St. Louis Arch or the McDonald's arches, or maybe a perfect set by Patrick, or a perfect shot by Alex, or something like that. So in this case, the vertex is at 0, 4. Well, that's easy enough. At 0, 4, this vertex is somewhere there at 0, 4. Wonderful. But then you have a point that passes through minus 1 and 6. So minus 1 and 6, well, that would be 2 more units up. So minus 1 and 6 is somewhere right there. So that's the picture of this parabola. 0 and 4 and minus 1 and 6 is the other point. Well, what's the equation of that graph? And the power of that is once you have the equation of that graph, well, now you can calculate every single point on that graph to infinity and beyond, right? So that's our job. We need to figure out a way to do that. Well, how are we going to do that? Well, if we can substitute the values of the vertex into P and Q, we learned that if we went and our vertex is at 0, 4, then clearly we know that P is 0 and Q is 4. And my vertex equation, or my x minus p squared plus q equation, should look like that. So the only thing I really need to know is how much Mariah has been done to this graph. In other words, how much stretching has been done. Mariah was our stretcher in class. So what's the A value here? So how do I do that? Well, I simply go and I say, well, if I simplify that x minus 0, I get that. I have this point, minus 1, 6. And all I need to do is use that point to solve, use that point to solve for A. We have to keep moving this around. So if I use that point to solve for A and I substitute x and y in there, I now have y equals ax squared. I substitute that in. I know you can just see that. And now if I take that equation and I solve it, I get 6 is equal to minus 1 squared is 1. 6 is equal to 1a plus 4. So if I take the 4 to the other side, I get 6 minus 4, and that means that a equals 2. So therefore, as I finish this question, as I finish that question, I now have the equation of this parabola is y equals 2x squared plus 4. Right? Can you think of an alternative way to do that? How could I have found out the a value without using substitution? Another student might say, well, look at what you did, Mr. K. I know that my basic parabola is supposed to go over 1, starts at 0, 0. Normally it goes over 1 and up 1, and minus 1. So that's your basic one. What did this graph do up here? Well, this graph, if you looked at your parabola and your imaginary axis, it went over 1 and went up 2. Clearly, this has been vertically stretched by 2. So another person might have just used inspection common sense and the work we did with transformation to calculate in their head. The algebraic way is better because in this method we can do it for any value of a. We don't just have to do integer values for a. Okay? So that's the method that's going to work every time, the algebraic way. Okay? In question 2, it said, okay, we got a different one now. We got write the equation of a parabola that has a vertex of minus 1, 3, and x-intercepts of 2 and 4. And sometimes it's helpful for you to draw it. But again, because you know the vertex, you can substitute minus 1 and 3 into that vertex, into your formula, and you know that this graph is x minus minus 1 squared, which is a times x plus 1 squared plus 3. You know that because of the vertex. This thing is 1 to the left and 3 up. How has it been stretched? And we need to use those x-intercepts there. So because the parabola passes through those points, you can choose either one of those points. And the good news is it won't matter which one you pick. You could pick either one. If we took the point 2, 0, we would plug in 2 and 0, and we would get y equals a times x plus 1 squared, plugging in 2 and 0, and we get that equation, which when we follow through and solve it for a, we end up with a equal to minus 1/3. I don't know, you couldn't quite see, but divide both sides by 9 and you get a equals minus 3 over 9, which equals minus 1/3. Therefore, the equation for this parabola is minus 1/3 x plus 1 squared plus 3. What else could we do? Well, we could be asked to find the equation of a parabola that passes through 115 and 5 minus 1. This is tricky. With its axis of symmetry at x equals minus 4. I want you to ponder this one, pause, and see what you can do with this. And once again, you're still using a times x minus p squared plus q. Draw this parabola is a good starting point. What does it look like if you draw it? To try and figure out what you actually know. Draw all the information you were given. All right? Now, if you draw it, 115, well, that's way up here. So that's 115. And 5 minus 1, okay, 1, 2, 3, 4, 5, 5 minus 1. So it's just a really, you could do this on a notepad if you wanted. So 5 minus 1 is down there. And then the axis of symmetry is at x equals 4. Huh. Do you know what the vertex is? Well, that's kind of tricky, isn't it? That's our problem. We're trying to stuff it into this. Equation, y equals a times x minus p squared, and we're pondering right now, which of those things do we know? Do we know p? Do we know q? Based on your diagram of information, think deeply, and you know that this is x equals 4. Do you know p? Do you know q? Do you know a? Pause. Think. Okay? Given that the axis of symmetry is 4, actually you do know p. You know that p is 4. You know that. You know that somewhere along that axis of symmetry, that's the definition. It cuts the parabola in half. Therefore, this parabola has been shifted over to the left, to the right 4. So that's the first thing you know. Now, the rest of it, we don't know how high it is, and we don't know what the stretch is. We need to use some algebra to find this, because really, this is kind of tricky to see what it might be. Where would you graph that so that you would have the vertex? How would you connect these dots, right? Well, the trick to this is going to be for you guys to use some math. We got to use both points, and we got to use some Math 10. We plug both of those points in, and you might say, well, that's not very helpful, Mr. K, right? Well, yes, it is. 115, when you plug it in, you get a nice little equation. Plug in 1 and 15 for x and y, and you get a nice equation of 15 equals 9a plus q. If you plug in the other point, you get a really nice equation of minus 1 equals a plus q. Now, if you remember your Math 10, you now have two equations with two unknowns. You will solve this system of equations by using substitution or elimination that you remember from Math 10. To solve a system, we can either add or subtract. In this case, we choose to subtract. And I know that's a little bit off the screen, so if you were to subtract these two equations, you end up with, when I subtract those two, you end up with 8a is equal to 16. So a is equal to 2. You go back, and if a is 2, you go back and you find out by subbing into the next value that q was, and you might say, well, how do I know that? Well, you got to pick one of those equations to go back in there and solve. And if you pick, say, this equation, right, I didn't show the work, but if you pick this equation and you plug in your a value of 2, minus 1 equals a plus q. If a is 2, minus 1 equals 2 plus q, then q is equal to minus 3. And so if you look at what we've got a is equal to 2, q is equal to minus 3, and now we can go back to our equation, and we can state our new equation. The equation is 2 times x minus 4 squared minus 3. A beautiful example of using a math that we have learned over the years. Okay. You have now completed, and I want you to complete the assignment that's on your formative sheet in class next day. Okay, good job.